Hey everyone. So in this lesson number 13, we are going to be writing division expressions. So we're writing expressions with division, which is different than the last few lessons. We've only been writing them with multiplication. So here is an example that I'll do up here real quick. So in the last few days, we've done things like we'll have 3 times, 2x plus 4. And this is a division expression, or sorry, this one's a multiplication expression, the ones we've been working on, because we're doing, this whole thing means 3 times, this is 3 times all of this stuff. So when we actually work it out, we're doing, 3 times 2x is 6x, and then plus, and then 3 times 4, is 12. So this is multiplication. We're using multiplication to solve those ones. So let me see if I can scribble all that out. Doesn't look like I can, so I'll just leave it up there. So let's get right to it. So in example number 1, it says, write an expression showing 1 divided by 2 without the use of the division symbol. So the first thing that we'll do is just draw a simple tape diagram. So we have one thing, so I can make a little one piece. So there's 1, and I'm dividing that into 2. So how can I divide that into 2? Well, all I gotta do is cut it in half, right? And then I have, this would be, I have 1, and I have 2 pieces. But the whole thing, this was one whole thing, right? The whole thing was one whole bar, and I divided it into 2 pieces. So what can we think about when we're dividing 1 by 2? Well, what do I have right here? This is really, is this 1? This is like 1 out of 2 pieces. This would be the second out of 2 pieces. So if I look at just one piece, if I'm looking at just how much is this first little piece right here, well, that's 1/2. So 1 divided by 2 is 1/2. And that's what can we determine from the model. So from the model, this is going to be weird if I'm writing with my finger, but we can determine that 1 divided by 2 equals 1/2. Okay, so, and you might be thinking to yourself, well, this says write an expression, why do we really need to use a tape diagram? Well, no, there's other ways that we could write an expression, right? An expression is just a mathematical, this is an expression down here, right? So what other ways can we write division? Well, there's lots of different ways we could write division. One way is you could write it like 1 divided by 2, right? That's like if we were doing a long division problem, you might set it up that way. Another way is we could actually say 1 divided by 2. That's another one. This second one's not really an expression because we're writing it out with words. But another one is, which you can see right here, the last one is, and this is kind of what we're talking about today, is another way you could write a division problem is as a fraction. And I've said that before, so 1/2. Okay, so let's move to example number 2. Example number 2 says, write an expression showing a divided by 2 without the use of the division symbol. So when it means the division symbol, it means this guy up here. We're not using this. That is the division symbol. So, kind of to help us start, we could say, all right, well, let's, just like I did up above, let's do a little tape diagram just to start. So we have a divided by 2. In this case, this doesn't stand for 1. This is a. So we have a. We don't know what a is, but, there we go. We got a. Now we're going to divide that in 2. So I'm going to slice it in half, and now it's in 2s. So over here on the left, I'd have, what does this represent? Well, this is the A, right? We took A and we divided it into two pieces. So that kind of looks like a 9, but this is an A. So over here is the same thing. So this is going to be A divided by 2, because it's the same thing. We got two of them. So from the model, we can determine that A divided by 2 is the same as A over 2. A over 2. Okay, so when we write this division expression using the when we write division expressions using the division symbol, we represent the dividend divided by the divisor. The dividend divided by the divisor. Okay, and that's, to see that as a fraction, it would be the dividend over the divisor. Now, I actually personally like writing fractions a lot, or division problems a lot more as fractions, because we're all probably very familiar with writing our fractions like this guy right here. Well, the problem with this is, this was for the problem 1 divided by 2, and the numbers are kind of backwards, right? You take the number that you're dividing up and you put it inside the little box, and then you take what you're dividing it into, how many things you're dividing it by, and you put that on the outside of the box. So when you're saying this problem, this is actually 1 divided by 2. And that just seems kind of weird to look at it like that. So the nice thing about fractions as division problems, as you notice when you're reading through this problem, this is A divided by 2, and it's in order. Well, with a fraction, you can think of a fraction as you read, a book left to right, and you read it also top down. So this would be A divided by 2. It's kind of in order. So I think it makes more sense. Okay, last example. So example 3 says, write an expression showing A divided by B without using the division symbol. So what we want to do is, without using the division symbol, well, we want it to be an expression, so I'm just going to take it and write it as a fraction. The nice thing about it is, since it's A divided by B, I can do A divided by B as a fraction. It's all nice in order. That would be the same thing as, we could also write it like this. That would be without it. But see, this way, it just seems weirder, right? It's A divided by B. What? That's kind of out of order. So, fractions. Yay, they make way more sense. B. Write an expression for G divided by the quantity H plus 3. Alright, so here we're getting a little bit more complicated. And I'll do this one in blue, because we have this as an expression for G, right? G divided by the quantity H plus 3. So what are we actually dividing it by? Well, we're not dividing it by a number. We're taking, G and we're dividing it by the quantity H plus 3. So we also have, this is the second part, right? H plus 3. So, but it's still kind of in order. So it's still G divided by. So we can start off, I'll put this one over here. So we have G divided by, and the quantity H plus 3. Well, how can I write H plus 3? Well, that's pretty easy. Just how it sounds. H plus 3. And notice when you're looking at it and you're reading it, this is kind of like those ratio things. They come in order, and there's some little keywords. It says G divided by. So divided by is, this key divided by, that's where our kind of division symbol is going. So everything over here should be before the division symbol. Everything over here should be after the division symbol. Now we're not using a division symbol though, so that's our fraction bar. So we have the g on the top and h plus 3 on the bottom. Okay, now let's take a look at C. C says, write an expression for the quotient of the quantity m reduced by 3 and 5. This one is a little bit more tricky because it doesn't say the divided by, and personally I think that the divided by, that makes it sound a lot more obvious. G divided by the quantity h plus 3. When it doesn't say divided by, you have to think a little bit more of where that actual division bar goes. So this one says the quotient of the quantity m reduced by 3 and 5. A lot of times in math, and is another way that we split things up. So we see that we have the quantity of m reduced by 3 and 5. And so we need to decide, we either have, this is either going to be, m minus 3 divided by 5, or it would be m divided by 3 and 5, maybe like 3 times 5. Well, that doesn't really make sense. If we have m reduced by 3, that doesn't really mean m divided by 3, right? So, but m reduced by 3, this one right here, well, I can write that out, right? We can say m reduced by 3. Reduced is you're taking something away, so that would be m minus 3. And we know we're looking for a quotient, because it says quotient right here. So we have m minus 3, and that ends up being and, so the and 5 means to divide. And so this can actually kind of be a little bit of a process of elimination type thing, because you know that, like I said before, m reduced by 3, that doesn't mean division. So that must mean m minus 3. But then we have and 5. Well, what happens with that and 5? Well, when our sentence tells us for the quotient of the quantity, and this is all we have to work with, right? So we know we're supposed to be dividing because it says quotient. So the and must mean to do and 5. So this is the subtraction problem and 5. We're finding the quotient of this and this. So that's kind of how that works. So notice in your exercises as you're working that there are different examples. So we have divided by, and there's also quotient of the quantities. Here's the quotient one. Moving down a little bit further, we've got some divided bys and some quantity ofs. So really think about what it means. You can kind of use process of elimination, and sometimes if you're really not sure, just write it out. Let's say that you weren't really sure with C, and you wrote, you said m divided by 3 and 5. What is that? 3 times 5. Does this look like the quotient of the m reduced by 3 and 5? Like what am I reducing here? It's like, when you're looking at it, doesn't really make sense. So then you could try something else. So it's okay to write it one way and go, that doesn't really seem so great, and try another way and see if it works a little bit better, because you might try one way or second way and they don't seem right, and on third try, hey, that makes way more sense. So don't be afraid of making mistakes, guys. Okay, hope that helps. Have fun.